What we're looking at today is the complex conjugate theorem, or complex conjugates. Complex conjugate says that if A plus BI, or the complex conjugate for A plus BI, is A minus BI. So if we're given A plus BI, its complex conjugate is A minus BI. If we're given A minus BI, its complex conjugate is A plus BI. That's it. It's also, the complex conjugate theorem states if A plus BI is a solution, A minus BI is a solution. If we have one, we have to have the other. So if we look at the first one here, 7 minus I, well, the complex conjugate of 7 minus I is what? That's it. 7 plus I would be the complex conjugate of 7 minus I. Questions on this here? Now, the first few problems didn't ask for this. When it's asking for the complex conjugate, it's not asking for their product. But there is something interesting that does happen when we do multiply the two together. So if we multiply 7 plus I and 7 minus I, well, we'll start off with 7 times 7, which is 49. 7 times I is going to be plus 7I. Negative I times 7 is going to be negative 7I. And negative I times I is going to be negative I squared. So if we multiply them together, we get this here. Now, when we combine like terms, 7I minus 7I, that is 0. Our I squared is negative 1. So that gives us 49 minus negative 1, which is the same as 49 plus 1, which tells us that it is 50. So the interesting things with complex conjugates are these conjugates, when we multiply them together, here the I terms cancel out. They simplify out and just give us a number. So the complex conjugate of 7 minus I is 7 plus I. If we multiply them together, we would get 50. Now, we could have done that in a graphing calculator. We could have said 7 minus I times 7 plus I is 50. So, let's look at the next one. What would the complex conjugate of negative 5 minus 5I be? It would be negative 5 plus 5I. Then if we wanted to multiply negative 5 plus 5I times negative 5 minus 5I is incidentally also 50. Questions on how we found the complex conjugate of these first two? Let's look at the next one. Negative 2 plus 4I. What would the complex conjugate be? It would be negative 2 minus 4I. And again, we could say negative 2 plus 4I times negative 2 minus 4I. And it tells us that it is 20. How about 3 minus 6I? What would it be? Well, part of it. No. It would be 3 plus 6I. Because if you're given A plus BI, its complex conjugate is A minus BI. If we're given A minus BI, its complex conjugate is A plus BI. So how about 10 minus 2I? It would be 10 plus 2I. Negative 4 minus 8I would be negative 4 minus 3I would be negative 4 plus 3I. And then we would have 8 plus 3i. Questions on complex conjugates? Let's look at two extras. Let's say negative 16i. What would its complex conjugate be? It would be 16i, because really we can consider it 0 minus 16i. So the complex conjugate would be 0 plus 16i. So we have this here. What would the complex conjugate of 9 be? Well, it might help to get it in A plus BI form, yes? So we could really say that we have what? 9 plus 0i, so its complex conjugate would be 9 minus 0i. So really the complex conjugate of 9 is 9, because we're changing the sign in front of I, our imaginary term, not a real term. So the complex conjugate of 9 is just 9. Questions on this here? All right, I need to make this a little bit bigger. Now, when we're dividing complex numbers, we have to get I, this imaginary number, out of the bottom of the fraction. Now to do that, what we're going to do is multiply the top and bottom of this fraction by the complex conjugate of the denominator. So we're going to multiply the top and bottom by 1 plus 2i. Now at this point here, we're going to focus on the denominator first. So when we multiply this out, we're going to distribute. So we're going to do 1 times 1 first, which is just 1. 1 times 2i is going to be plus 2i. Negative 2i times 1 is going to be negative 2i. And negative 2i times 2i is going to be negative 4i squared. Now we can do some simplifying. 1 doesn't have any like terms. It's not going to simplify at this point. Our 2i minus 2i is 0. And I squared we have to simplify. And it's going to simplify to negative 1. Telling us that we have 1 plus 4, which is just 5. So what's nice about that is when we multiplied the top and bottom, specifically the denominator, by its conjugate, we got rid of the I term. That's the whole point. We can't have I in the bottom of the fraction. Because really we're saying we're dividing by this imaginary number, the square root of negative 1. We can't have that. We don't want to leave it in that form. On top, we're going to have to multiply 2. 4 times 1 is going to be 4. 4 times 2i is going to be plus 8i. 3i times 1 is going to be plus 3i. And 3i times 2i is going to be plus 6i squared. Now 4 at this point doesn't have any like terms. But our 8i and 3i are like terms. They'll add together to give us 11i. We do have to replace I squared with negative 1. Well, 6 times negative 1 is negative 6. Combine like terms, negative, or 4 minus 6 will give us negative 2. So we have negative 2 plus 11i over 5. Now if we rewrote this in A plus BI form, we split the two fractions apart, telling us that we have negative 2/5 plus 11/5 I. If one of those reduced or simplified, we'd simplify it. Questions on this here so far? Let's look at the next one. 1 minus 4i over 2 plus 2i. 2 plus 3i. just like the previous one, we're going to have to multiply the top and bottom of this fraction by its complex conjugate of the denominator. So we look at the complex conjugate of the denominator, which is going to be 2 minus 3i, and we're going to multiply the top and bottom by this 2 minus 3i. So here, we're going to distribute through. 2 times 2 is going to give us 4. 2 times negative 3i is negative 6i. 3i times 2 is going to be plus 6i. And 3i times negative 3i is going to be negative 9i squared. Now, we'll go on and multiply the numerator 2. 1 times 2 is 2. 1 times negative 3i is negative 3i. Negative 4i times 2 is negative 8i. And 4i times negative 3i is plus 12i squared. At this point here, on top and bottom, we can combine like terms. So we'd have 2 minus 11i plus 12 times negative 1. On bottom, we'd have our 4. 6i, negative 6i are going to cancel. And as before, I squared is negative 1. We have to replace it there. Now, negative 1 times 12 is going to be negative 12. On bottom, we really have 4 plus 9. 4 plus 9 on bottom is 13. 2 minus negative 12 is, or 2 minus 12 is negative 10, giving us negative 10 minus 11i over 13. Or we can say negative 10 thirteenths minus 11 thirteenths I. Questions on this here? We're starting to get the hang of this. We kind of see how this works, yes? All right. Are you ready for the next one? So, our next one's 2 plus 5i over 4i. Well, up to this point, the graphing calculator has been able to do all of these. Yes? So, alpha, y equals, enter, 2 plus 5, second decimal to get us I, over 4 I. Alpha, y equals, enter. Don't type it in, see what we get. You good? I have a feeling they give you an error. So now for the graphing calculators that we have, we can't type it in as a fraction. The 30XS or the 84 plus CE, the color editions, the ones after this will let you type it in as a fraction. Here we're going to have to type it in this form. So we're going to have to type the numerator in parentheses. So we'll do parentheses 2 plus 5i. Close parentheses, because fractions are just another way to say divide. We can hit the division sign, parentheses 4i. Close parentheses. Once you get it typed in, hit enter. See what it tells you. I believe it gets us here, yes? Everybody get to this point. Okay, let's all get here first. Because we can put it as this here, but for the most part, these decimals aren't bad, but we would prefer them as fractions if we can get them to fractions. Able to get this here. Hit math, enter, enter. Because when we hit math, the first thing is fraction. So if we say enter, yes, I want to convert this to a fraction, then one more time to make it convert it to a fraction. So what it tells us is that 2 plus 5i over 4i is 5/4 minus 1/2 I. Able to get that to work? So division, so divide.
How do you do the
Parentheses, 4, and then I, second decimal. Divide. Yeah. Yep, parentheses, enter. And it gives us the 1.25 minus 0.5i math. So right below the, yep, enter, enter. Yep. Because the first option under math is fraction. So it's saying take the previous number, the decimal, and convert it to a fraction. You're welcome. That's it. So let's look at, because the next one after this is 1 plus 4i over 2 minus 3i. So again, parentheses, 1 plus 4i divided by 2 minus 3i. And as we can, so you got the 1.25 plus 0.5i. So we're going to go math, enter, enter. Yep. Because under math, if we wanted to convert it back to decimals, we would pick the second one. But since we want to convert it to a fraction, we just pick the first one, enter. So it tells us that it's negative 10/13 plus 11/13 I. Questions on this here? We feel comfortable with this here?